It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 8 here, where we're going to continue working with systems of inequalities, but we're going to be modeling with them just like we did with systems of equations. So let's try this opening exercise here to get our minds back into the system, working with systems of inequalities. Determine if negative 3, 4 is a solution to this system. Well, how do I check if something's a solution? Well, we plug it in. Negative 3 goes in for x, and 4 goes in for y. So that's what we're going to do. We're going to plug it in one at a time. 2x plus 3y, is that greater than or equal to 6? Well, doing a little mental math here. Negative 6 plus 12 is 6. Is 6 greater than or equal to 6? It is. So this is a true statement. So that one's good. Let's try this second one here. 3x plus 2y is less than or equal to 6. Negative 9 plus 8 is less than or equal to 6. Is negative 1 smaller than or equal to 6? Well, the answer to that is yes. So it works for both. So we're going to say negative 3, 4 is a solution to the system of inequalities, right? It's a system here. It's a solution to the system of inequalities because it makes both inequalities true. All right, so it is a solution to the system because it makes both of them true. That's how I become a solution to a system. When I plug that point in, it works for both of them. So a high school drama club is putting on their annual theater production. There is a maximum of 800 tickets for the show, right? When you have a show or a concert, you don't always sell every single ticket. So there's a maximum of 800 tickets. The cost of the tickets are $6 before the day of and $9 on the day of the show. So if you buy it ahead, you get a little bit cheaper price. To meet their expenses of the show, they must sell at least $5,000 worth of tickets, right? They spent money. They've got to break. That's the break-even point. They've got to make more than $5,000. So write a system. That means 2 inequalities we're working with here. So I'm not writing equations. So this is a money total problem, just like when we dealt with systems of equations. So let's deal with the money. $6 the day before, we'll call those X, and $9 the day of. Well, it doesn't equal 5,000. This is where we've got to think. At least 5,000. And people see least and think less than. Well, 5,000 is good. If I make 4,000, is that okay? No, 4,000 is not good. 6,000 is good, though, because that's at least 5,000. So I want to be bigger than or equal to 5,000. So notice I'm writing a system of inequalities here. 6x plus 9y is bigger than or equal to 5,000. And now the total, the only thing I haven't used yet is the 800 tickets. So the total, we always just find the sum, x plus y. I've only got 800 tickets. I can't sell 900. 900's no good. 700? Yeah, there's enough seats. So I've got to be there is at most 800 seats. I've got to be smaller than 800. So this is my system of inequalities. You got to use a little bit of common sense here when reading these words. What does at most mean? What does at least mean? So that's how you figure out what sign, greater than or less than, to use. The club sells 440 tickets before the day of the show. That's my X. Is it possible to sell enough additional tickets to meet the expenses? So 440 is X, and I want to know, do they have enough money? So let's look at the money here. 6 times 440, because that's X. I don't know why, has to be greater than or equal to 5,000. So I've got to multiply this together here. I don't have a calculator. So I'm going to do this quickly in my head. And by in my head, I mean using the standard algorithm. Oh, I need to get my calculator up. I'm going to hit it and see how long it takes for it to come up. Well, I have to solve for y, so I'm going to subtract that 2640. So 9y is bigger than, here it comes, it's loading. It's too late at night for me to be doing this in my head. There we go, TI Smart View. No, I don't want to update. 5,000 minus 2640, 2360. Well, I want just y. Right, how many tickets do I have to sell on the day of? So divide that by 9. 262.2222. Which means I've got to sell more than that. And I can't really sell 0.2 of a ticket, so I have to sell 263 tickets. Well, the question is, can I? Can I actually get to 263 tickets? That's where this 800 number comes into play. 440 and 263, well, let's see what we get here. 703, that's smaller than or equal to 800. So can I do it? Yeah, as long as I sell 263 or more tickets, we're good to go. Okay, so working with these systems, sometimes we have to plug numbers in to see if they actually work. So if they sell 263 tickets on the day of the show, they'll be good. They'll be good because they'll make enough money and they'll be under 800 people. We got one more and then we'll call it a lesson. We're going to keep this video somewhat short. Marissa needs to hire at least 10 staff members for an upcoming project. She needs to hire at least 10. The staff members will be made up of junior directors. So junior directors get $640 a week. Senior directors get $880 a week. And she's only got $9,700. Write a system of inequalities. Well, this is another money total. So let's deal with the money. I always like to deal with the money. Money, money, money. Junior directors are $640 each. Senior directors are $880 each. Well, what inequality, system of inequalities, what inequality goes here? Can she spend $10,000? No. I know it says more than, but that more than, no more than. She can't go above that. 10,000 is no good, so I've got it to be smaller than. That's a less than there. The only thing I haven't used is she's got to hire 10 people. So junior directors and senior directors, I need at least 10. 11's good, 12's good, 9 is no good. So I've got to be bigger than or equal to 10. That's my system of inequalities. Money, 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 and then the total. Marissa must hire 2 senior directors. She has to hire 2. So how many junior directors can she hire? Well, she has to hire 2. Let's plug that in. How much money does she have left over? I don't know juniors, but I know she hired 2 seniors. How many can she actually still afford? Well, 640J plus 1760. And that one I did in my head there. I should probably, no, I'm good. I just checked it in my head again. Minus 1760. This I'm not going to do in my head. 9,700 minus 1760. 79400. I'm going to divide by 640. Going to divide by 640. 12.4. So J has to be smaller than 12.4-ish. So can she hire 13? No, it's got to be smaller than 12.4. So how many can she hire? She can hire 12 juniors. If she only gets 2 seniors, she'll have enough money for 12 juniors. That's what she can hire, because J has to be smaller than 12.4. Can she hire 4 seniors and 10 juniors? So let's see. Does she have enough money for 10 juniors? Right, 640 per junior, 880 for each senior. Is that smaller than 9,700? That one I can definitely do in my head. This one I'm not risking the embarrassment. 3520. Let's see, does she have enough? So I'm doing that number plus 6,400. 992. Oh, Marissa, not looking good for you. They cost too much. No, she cannot afford it. She needs $9,920. She's constrained. She has at most 9,700. Okay, so we're going to be working with these modeling problems with systems of inequalities where you've got the total, and the money. Total, and show me the money. And we'll see you guys as we keep working with these systems of inequalities.